Okay, welcome back. We're in section 5.5, which is problem solving using radical equations and expressions. So the very first thing that we're going to talk about in this section is the Pythagorean theorem. The Pythagorean theorem essentially talks about measurements on a triangle, but specifically a right triangle. And a right triangle is a triangle that has a 90-degree angle in it, right? And we would call the leg of the triangle that is on the opposite side of that 90-degree angle the hypotenuse. So that's the hypotenuse, and most of the time we just call it the letter C, because we don't like writing big words. Mathematicians hate anything that can't be condensed to a single symbol. But we'll just call the other ones just A and B. And it doesn't matter which one of these is A and which one is B, but it does matter that this one is C, because in the Pythagorean theorem, it states that if you take A and square it, and add that to the square of B, then that should be equal to the square of C. And again, this is for a right triangle. And so, this is why it's important, is because the C, the hypotenuse, has to be the one that's on the right-hand side, or it's the one that's alone. But we can figure out, if we know two sides of a triangle and we know that it's a right triangle, then we can figure out the other side using this theorem. So let's take a look at a few examples of this. If I have, and there's a couple of nice ones. If I have a triangle that has sides of 3, 4, and I don't know what that hypotenuse is, well, this is on the hypotenuse because it's on the opposite side of this 90-degree angle. That tells me that this a squared plus b squared equals c squared, and therefore a I can say is 3. Again, a and b don't matter which one is which, but this c squared is the important one to make sure you get right. But 3 squared is 9, 4 squared is 16, and so that tells me that 9 plus 16, which is 25, is the square of c, or 25 is c squared. So to figure out what c is, we just square root each side, and we know that the square root of 25 is 5. When we say c squared is 25, c could be either 5 or negative 5, but it doesn't really make sense to call it negative when we're talking about an actual triangle, right? When you get into trigonometry, you might start talking about directions of movement, things like that, where this negative might make sense. But for now, all we really care about is the actual value, the magnitude of the length of that side. That gives us c is equal to 5. And we've solved that triangle. All right, let's take a look at another one. Another nice one is, let's say this is 5 and this one is 12. Okay. Then again, we're looking for c. Okay. Well, this tells us that 5 squared plus 12 squared is equal to c squared. Okay. 5 squared is 25. 12 squared is 144. If I add these two together, I get 169, which is nice again, because if I square root this, well, 169 is 13 squared, so c is 13. Okay. Again, these are two nice triangles where I end up with integer values. That's not always the case, and it's typically not the case. Any random right triangle that you find out there in the universe, it's probably not going to work out this nice. Let's see. let's just grab some numbers. Let's say that's 6 and this is 8, right? Just kidding, that one's gonna work. Let's say this one's 10, 11, I don't know, it doesn't matter. Okay. If that's 6, that's 11, and I don't know the hypotenuse, that means that 6 squared plus 11 squared is c squared. 6 is 36. 11 is 121. If I add these things together, 157. If I square root each side, well, 157, it's not anything squared, all right? And I would know that because I just did 169. The square root of 169 is 13. I know that the square of 12 is 144, right? And this is 157, somewhere between there, so this is 12 point something, I don't know, right? But I can't really simplify this. 157 is not divisible by 2, or 3, or 5, or 7, or 11, or 13. It's not divisible by anything. It's actually a prime number, and so I'm done. I can't simplify this any further. That's it. Right? Okay. Let's take a look at another one. Let's go, I don't know, 4 and 7 perhaps? So this again tells us that 4 squared plus 7 squared is equal to c squared. 4 squared is 16, 7 squared is 49. If I add these two together, I get 65. Right. And therefore, if I square root each side, then that tells me that c is whatever the square root of 65 is. And I don't know if I can simplify this, so I'm going to check, right? I know that 65 is divisible by 5 because it ends in a 5, right? And so that gives me 13, and that's it. I can't do anything with that, right? I've got two prime numbers, 5 and 13. I can't simplify this any further, and so that's it. I'm left with 65, a square root of 65. And so that's what I would write, as c is simply the square root of 65. All right, let's take a look at a different approach here. The last couple of examples we found c, but what if we knew c? Let's say that c is 20. And I know this leg over here, let's call this maybe 4. Okay. And what I want to find is whatever this leg is, let's call it b. Right? Well, I can still use that a squared plus b squared equals c squared. A can be 4, b can be b, that would make sense, and then c is 20, right? That's the important thing, is that the 20 ends up in the c. But this turns into then 4 squared plus this unknown value squared here is equal to 20 squared. And now my unknown value is one of the two on the left, right? But this is 16 plus b squared equals, and 20 squared is 400. And so I'll just minus 16 from both sides. And so I have b squared is equal to 384. And so if I square root each side, then that tells me that b is equal to the square root of 384. And if I can simplify this, I will want to. So I will. I'll divide both, not both, I'll divide it by 2. 384 divided by 2 is 192, which is divisible by 2 again, which gives me 96. Right? Yeah. Still divisible by 2, so 2 and 48. I think this seems wrong, but let me check. 192, 96. Yeah, no, we're good. 48 still divisible by 2, and 24 divisible by 2 again, and 12 divisible by 2 again, 6 divisible by 2. There's a lot of 2's there. Right? And so since I'm under a square root, there's one group of 2's, 2 groups, and 3 groups of 2. So 2 times 2 times 2 is an 8 on the outside. I've got a 2 and a 3 that stay in, so the square root of 6. And so I have B equals 8 root 6. If you like, you can throw this into a calculator depending on what you're looking for. And so if I took the square root of 384, throw it into a calculator, this gives me something around, I would write B. These little squiggles mean that I've estimated it and I'm going to round it at some point. But this is somewhere around 19 point, about 6. And then there's, in our book, if you read below, there's a couple of examples of, say, like a ladder. We've got a building, I don't know, maybe it's on fire, whatever. A fireman comes, throws his ladder up here, right? That makes a right angle. The building, hopefully, unless we're in, Italy. But we've got that building making a right angle with the ground. And therefore, if this fireman throws up, let's say his, I don't know, 22-foot ladder, and this window that he has to get to, let's say, is 16 feet off the ground, then the question is how far away from the building is the base of the ladder, right? So you might see some question like this, and this is just an application of that Pythagorean theorem, right? Where this 22 is my C, it's the hypotenuse because it's on the opposite side of the 90-degree angle. And so this, instead of a question mark, I'm going to label as X, if you like, or B, or A, or pick a letter and go and run with it. But this tells me then that I have 16 squared plus this unknown X squared equals 22 squared, right? Well, 16 squared is 256. 22 squared is something. 484. Okay. Subtract the 256 from both sides to isolate that x squared here. That gives me x squared is 228. And therefore x is the square root of 228. Now in math, if you want an exact answer, you would have to simplify this by factoring out. So let's do that. I'm going to erase my beautiful burning building picture here. $228 is divisible by 2, giving me 114, which is divisible by 2, giving me 57, which is not divisible by 2 anymore, but it is divisible by 3, and that is 19, and I'm done, right? And so I've got a 2 that I can pull out, right? And then I would have to take the 3 times 19, which is 114 again. That's the exact answer, right? If you go tell a fireman, hey, go put your ladder 2 times the square root of 114 units away from the building, he'll probably throw you into the fire. That's not helpful to him. So if you throw that into a calculator, the square root of 228, we get an estimate of x is somewhere around 15.1. feet, yards, meters, whatever we're talking about, right? Okay. All right. Let's take a look at another application of roots. Square roots show up in physics quite a bit, but there's an example if you scroll almost all the way down to the bottom in this lesson, there's an example about speed. And it says the speed in miles per hour that a car is traveling as it goes into a skid on asphalt can be determined by the formula S equals the square root of 21d. Right? So S is in physics a lot of times, well, I won't get into that. S in this case is speed, and then D in this case is distance. So, depending on how fast a car is going, right? I mean, there's a relationship between how fast a car is going and how far it's going to skid when it stops, right? And this is kind of an estimate. It depends on things like the tires, the vehicle itself, the conditions of the road, things like that. But for this particular example, we have this. There's a root involved. And so, let's say there's an accident and the officer on the scene goes and measures the distance. This is like the distance of the skid. If the officer measures that distance, he can then say, well, multiply that by 21 and take the square root, and that's about how fast this guy was going, so he can, book him into jail or not, I don't know. But let's say a car is traveling 150 miles per hour. How long is the skid? So I know how fast it's going, right? That's the speed. So I know that I have 150 equals the square root of 21d, and I want to solve for d. That's my goal here, is to figure out what d is. How do I get it by itself? Well, I can square both sides, and squaring undoes this square root, right? So I have 150 squared, which is 250, and then 2 more. I think that's right. I'm going to double check that. Just kidding, I was wrong. It's 225, 22,500 that is. So that's equal to now 21d. And to solve completely for d, I'm going to divide each side by 21. And then d is this 22,500 divided by 21. We would round this. We're not particularly interested in, trying to simplify that to an exact answer. So I would take that divided by 21 gives me about 1,071 feet, which is one hell of a skid if you start skidding at 150 miles an hour, right? But makes sense. Another physics formula, let's take a look at just one more, that next example below this one says the formula V equals the square root of 2gh, 2 times g times h. This describes the velocity of an object in feet per second of some object falling from a height h in a gravitational field g. Right? So since we're in feet, let's use English measurements of feet and feet per second. Then G, in that case, then G is equal to 32 feet per second squared. Right? These units don't mean a whole lot, it doesn't matter. But if we're going to use feet, G is 32. If you're in the metric system, meters, and then G would be 9.8. Right? But if I have an object, and it falls from a height of 50 feet, I want to know how fast it's traveling before it hits the ground. And so then I would say that the velocity is equal to the square root of 2 times G, we said was 32, and that height was given as 50. Right? So it's simply 2 times 32 times 50, and then square root that. So this is 3,200. Could have done that in my head. 2 times 50 is 100, times 32 is 3,200, but too late. And then the square root of that is about 56. That's feet per second, which is pretty fast. All right, thank you, and we will see you for the next one.